Something mysterious is out there. Voyager 1, the most distant human-made object in space, has just picked up an anomaly at the outer edge of our solar system. It's something that defies explanation, something that shouldn't be there. Is it a malfunction? An undiscovered cosmic phenomenon? Or could this be the first real sign that we're not alone in the universe? Stay tuned, because what Voyager 1 just encountered might be the first confirmation of an alien presence. Launched in the late 1970s, Voyager 1 had a clear mission: explore the giant outer planets, then venture into the great unknown beyond our solar system. It flew past Jupiter, capturing unprecedented images of its colossal storms, and then swept by Saturn, revealing the mesmerizing detail of its iconic rings. But it didn't stop there. By 2012, Voyager 1 had crossed the Heliopause, the invisible boundary where the sun's influence ends and interstellar space begins. This moment was already etched in history, but now, over 40 years since its launch, Voyager 1 has stumbled upon something so bizarre that even the most seasoned scientists are left scratching their heads. What it just uncovered is not only unexpected, it's deeply unsettling. And believe it or not, this may be just the beginning of discoveries that will truly leave you speechless. The heliopause, often described as an invisible barrier, acts as a shield, blocking most harmful cosmic rays and high-energy particles that drift through deep space. But something strange is happening at this boundary, something no one saw coming. Voyager 1 is detecting unusual vibrations in the magnetic field, disturbances that shouldn't exist. These rippling waves are moving through space in ways that defy current understanding. The data simply doesn't make sense. Scientists long believed this region would be quiet, almost tranquil, with only subtle magnetic fluctuations. But the signals Voyager 1 is picking up are telling a much different story, one that raises a startling possibility. Something may be pushing back at the very fringe of our solar system. So what's behind these mysterious waves? That's the million-dollar question. Some scientists suggest it could be an entirely new form of energy, an unknown interaction between the solar wind and something else lurking in interstellar space. It seems to be following rules we don't yet understand. Could the heliopause actually be acting like an antenna, tuning into signals from far beyond our known universe? If that's the case, who, or what, is sending them? Is it possible that we're just now overhearing an interstellar conversation that's been happening for billions of years? Some scientists suggest that what Voyager 1 is picking up might be part of a massive, unknown energy grid stretching across the galaxy. If true, the spacecraft may have uncovered something revolutionary, an invisible force that connects solar systems, perhaps even influencing how stars and planets move through deep space. That would mean our solar system isn't just drifting alone through the void, but part of something much larger than we ever imagined. Voyager 1 wasn't just transmitting data. It was revealing that space is far more dynamic than we thought. Picture space not as a silent, empty expanse, but as a vast network of unseen forces, an intricate web spanning the galaxy, forming hidden bridges between stars. These energy currents could be carrying messages, linking entire solar systems in ways we're only beginning to comprehend. Every transmission from the satellite feels like a whisper from the edge of existence, teasing at a greater mystery we haven't yet unraveled. We believed we had a firm grasp on space, that the borders of our solar system were well understood. But with each new discovery, the satellite challenges everything we thought we knew. Strange signals, unexplainable forces, and unexpected interactions are emerging from the fringes of our solar neighborhood, phenomena that don't fit into our current understanding. And then comes the ultimate question: what lies beyond our solar system? If these energy currents are genuine, could they be evidence of something more? Something intelligent? Something observing us? For centuries, we've questioned whether we're truly alone. Now, with every new piece of data, that question grows louder. This satellite has already broken through the limits we once believed unbreakable. What if it's been sending us answers this whole time, and we just haven't learned how to listen? Even Elon Musk has spoken out, calling the satellite's findings a wake-up call for all of humanity. It's already reshaped what we thought we knew about our solar system, and now, it's pushing us to ask even deeper questions. What secrets is the universe still hiding? What lies beyond the limits of our current understanding? This satellite may not last forever, but the impact of its discoveries will echo through generations. We live on a small planet, floating in the vastness of a largely unexplored galaxy. Yet somehow, this satellite continues to defy the odds, reminding us that we've only just begun to uncover the mysteries out there. If we don't keep pushing boundaries, if we don't explore, we risk staying grounded on this one tiny world, forever wondering what might have been. The signals are coming in. The clues are out there. The real question is, do we have the courage to follow them? This satellite has made history, but it's not alone. Over the decades, countless satellites have changed the way we see space, and even how we live our daily lives. Since the beginning of space exploration, we've launched satellites with one goal: discovery. Some made breakthroughs, others failed, and a few are still quietly orbiting Earth, doing their job. Take it back to the late 1950s, when the Soviet Union launched Sputnik 1. It was just a shiny metal sphere with a radio signal, but it proved one thing: we could put objects in orbit. That little satellite sparked global panic and jump-started the space race. Then came Sputnik 2, carrying Laika, the stray dog from Moscow who became the first living creature to orbit Earth. It was a turning point, both technically and emotionally, showing how far we were willing to go to explore the unknown. The Hubble Space Telescope revolutionized space exploration. Freed from Earth's turbulent atmosphere, Hubble had a crystal-clear view of the cosmos, capturing stunning images of galaxies, nebulas, and supernovae. But it wasn't all smooth sailing. Hubble launched with blurry vision, requiring multiple repairs. Once NASA resolved those issues, though, it became one of the most powerful instruments in astronomy. While Hubble gazed deep into the universe, the Mars Reconnaissance Orbiter, launched in 2005, turned its attention to the Red Planet. It delivered high-resolution images that helped scientists map the Martian surface, identify potential landing sites, and search for signs of water. With every new image, Mars began to look more and more like a place humans might one day explore in person. Then there's the Chandra X-ray Observatory, which launched in 1999. Unlike optical telescopes, Chandra detects high-energy X-rays emitted by dying stars, distant galaxies, and black holes. It gave us a whole new perspective on the universe, revealing just how active and extreme even the darkest corners of space really are. Back on Earth, the Global Positioning System, better known as GPS, quietly transformed everyday life. Originally developed by the U.S. military, GPS has become an essential global tool. From airline pilots and delivery drivers to anyone looking for a nearby coffee shop, people around the world rely on GPS to stay connected and find their way. And of course, no conversation about space would be complete without mentioning the International Space Station, a monumental achievement in global cooperation, built in the late 1990s. This massive orbiting laboratory has served as a home for astronauts from across the globe, conducting experiments in microgravity that simply aren't possible on Earth. It stands as a powerful symbol of international cooperation, proof that even when nations disagree, they can still come together to advance science. Then there's Starlink, SpaceX's ambitious project to blanket the Earth in a network of small satellites, delivering high-speed internet to even the most remote locations. It's a potential game-changer. But not everyone is on board. Astronomers have raised concerns that the satellites interfere with views of the night sky, and others worry about the growing risk of space debris. Whether Starlink becomes a groundbreaking innovation or a cautionary tale is still uncertain. Voyager 2 had an even grander mission, traveling farther and capturing closer views of planets no spacecraft had ever visited before. Launched in late summer 1977, it was designed to go beyond, to explore more than its twin, Voyager 1. While Voyager 1 made a quick pass by Jupiter and Saturn before heading into deep space, Voyager 2 took the long way, setting its course for Jupiter, Saturn, Uranus, and Neptune, worlds its sibling would never approach. This incredible journey was made possible by a rare planetary alignment that allowed the spacecraft to use each planet's gravity as a slingshot, boosting it from one to the next like a cosmic expressway. With clever engineering upgrades, Voyager 2 was ready to make history. What truly set it apart wasn't just its ambitious itinerary, it was how it was equipped to handle the challenges ahead. Its cameras, for instance, had to be specially adjusted to function in the dim light of the distant ice giants, Uranus and Neptune.